My name is Najmi Farah binti Jamin, and I would like to explain about the introduction of our group assignment topic, which is numerical differentiation. Numerical differentiation approximates derivative by using discrete data, which is essential for analyzing complex functions. So for the first derivative, it will indicate the rate of change, while the second derivative will reveal curvature, stability, and inflection points. For example, methods like forward difference, backward difference, and central difference will be vary in accuracy and efficiency. And for the central difference is more preferred for higher accuracy because it uses points on both sides of the target. While forward and backward differences method may introduce more errors, especially when the functions is rapidly changing.
Hello, my name is Mukiming, AE230074, and now I will present about the manual calculation of the first derivative. And the first method we use is two-point forward, and the formula is fx plus h minus fx over h, and the value for two-point forward we calculated is 3.19. And the second method we use is two point backward. And the formula is fx minus fx minus h and over h. And the value for the 2 point backward is 2.7500. And the third method we use is 3 point center. And function is fx plus h minus fx minus h over 2h, and the value for 3 point center is 2.9700. And the fourth method we use is 3 point forward, and the formula is negative minus 3 fx plus 4 fx plus h and minus fx plus 2h over 2h, and the value for the 3 point forward is 3.4900. And the 3 point backward formula is 3fx minus 4fx minus h plus 4x minus 2h over 2h. And the value for the 3 point backward is 5.1550. And last but not least, the 5 point method. The formula for the 5 point method is negative fx plus 2h plus 8 fx plus h and minus 8 fx minus h and plus fx minus 2h over 12h, and the value for the 5 point method is 3.4208.
So for the simulation of the first derivative, I have already do it in MATLAB by running the coding, and I have successfully gained the same answers as the manual calculation. So we have 6 types of methods for the first derivative, which are for 2 point forward, 2 point backward, central, 3 forward, 3 backward, and 5 point. This is the methods and the coding that I have run in MATLAB. So for the first one, which is 2 point forward difference, I have included the input parameters based on the data given. The X will be 2019 until 2023, which for the years, and the F will be the data of production of semiconductor in billions. The X is 2021, and the step size, which is H equal to 1. So for the forward difference formula, we need to find X, which is equal to 2021. We have set the X to 2021, and this is the formula for forward difference. F x naught plus H minus F x naught over H, and then we can display the result by using 4 decimal places. So this is the same. We have obtained as the manual calculation, which is 3.1900. Okay. So for the next one, we move on to the 2-point backward. Okay. The input parameters still the same. We do not change anything, but we change the backward difference formula. Okay, this one to find the first derivative. Okay, and we also obtain the answer in 4 decimal places because of this command. And we run it, and we have obtained 2.7500. Okay, the center one is also the same because we do not change anything for the input parameters, but we only change the central difference formula by using the formula given. Okay, and then we run it and obtain 2.9700 for the central difference at x equal to 2021. Okay, the next one would be the 3-forward difference, 3-point forward difference. Okay, and this is the equation, and we gain 3.4900. So we can clearly state that it is easier to do the simulation in MATLAB for this topic because it is very straightforward. We only insert the equation and not change anything, especially for the input parameters. Okay, this one is for the 3-point backward. We obtain 5.1550. Okay, the same as the manual calculation. And for the last one of the first derivative, which is 5 point, okay, the formula is quite long. Okay, I have inserted the formula into this line 918, run it, and gain 3.4208 at x equal to 2021. And that's all for the simulation of the first derivative.
Hello everyone, my name is Ming Huang and my trace number is C230061 and I will present about the manual calculation for second derivative. So as we can see, the value of the table we will tap from the statistic graph and we chosen the years which is from 2019 until 2023. And the method that we need to calculate the second derivative, which is that we have two methods, which the first is 3-point center and the second is 5-point. For the 3-point center, we are using the equation of 3-point center, which is fs plus hash minus 2fs plus fs minus hash over hash squared. So we will substitute the value from the table inside this equation, and we will get the 3-point center of second derivative value, which is 0.4400. And next, for the 5-point, we're also using the 5-point equation, which is negative fs plus 2 hash plus 16fs plus hash minus 30fx plus 60fx minus hash minus fx minus 2 hash over 12 hash squared. So we're using the same method. We substitute the value from the table inside this equation, and we will get the 5-point second derivative value, which is 0.1625. And that's all the presentation of second derivative manual calculation. Thank you.
Hello everyone and good morning doctor. My name is Sujijan. Number 3 is CE230078. So this is my group member and I will simulate in the MATLAB for the second derivative, which is for this is I will calculate for the 3-point different, 3-point center different. So the data given is years and also the semiconductor production in billions, which is when years 2019 for the production is 28.76. For the 2020, the production is 26.7. And for the 2021 is for the production is 29.45. For the 2022, the production is 32.64. And for the last years is 2023, the production for this years is 35.23. So first we need to calculate for the step size, which is after we put the formula and we will get the step size is has equal to 1, which is the 1 year is the for the step size for this question. And after that, we need to calculate for the years of for the years 2021, which is the industry. And this is the formula for the 3-point center. And after that, we need to display the result. This is the coding for the display the result. Then we will get the 3-point center difference second derivative at the 2021, which is the result is 0.44. And also same with the manual calculation. And this is for the MATLAB simulate. So that's all for me. Thank you very much. Alright, hello everyone and good morning doctor. In this video, I will continue do for the 5-point central difference method for the second derivative in the same question. So this one is the data given, which is the years and also the semiconductor production in billions. So the data is same and the step size also is same, which is has equal to 1 year. And this coding is for the for the NaN for the points not calculate, which is cannot calculable. So and for now we need to write the coding for the formula, which is according the 5-point center difference method. And this is for the coding for showing the display result. And then we just press it and it will come out like this. And for the NaN is cannot calculable. So only got the result is when years of 2021, the value is 0.1625, which is same with the manual calculation. So that's all for me. Thank you very much.